Awesome. Thank you, Justin. And thank you for having me back here. And so my name is Monier Jalal. I'm the VP of Marketing at CertiK. If you don't know who CertiK is, we are a Web3 blockchain security company, end-to-end security from all things that involve KYC services to really effective auditing processes with projects to on-chain monitoring and even pen testing. So we do a ton of stuff. What I want to cover today in this session is the subject of Web3 security. In particular, insights around Web3 security, what's been happening in the market, and tools and best practices for securing your blockchain protocols and smart contracts. So with that, let's get going here. So to understand why we secure crypto projects, we first need to understand the mind of the hacker and what they target most. So first, we have to have a look at the most common types of attacks, which involves social engineering and phishing attempts on users through particular social media platforms. We probably all have seen these types of attempts where it involves luring the user to click something in order for them to gain access to information or credentials, then to carry out an exfiltration of some kind. So that's the first. We then have web UI attacks, which are your typical website or web application attacks where hackers will try to exploit Web 2 vulnerabilities, resulting in the takeover of that website or application. And actually, we're seeing a little bit more of that happening on the Web 2 side, given the integrations that are happening with Web 3 and Web 2, social media, marketplaces. So that element is coming into the security side of the fence. Typical types of vulnerabilities for Web 2 are things like SQL injection, cross-site scripts, attacks, and so you'll see those happening. Then we move into privilege access issues where private keys are compromised through some way, example through phishing attacks, and those credentials are then used to further compromise other parts of the system or network, in particular the Web3 network. So all of what I've described, all these attacks are typically what we refer to as Web 2 security attacks or hacks, and we're starting to now see a lot of elements of Web 2 being attacked by hackers, as I mentioned, to get into Web 3. Just as an example from a social media perspective, and the types of attacks that have happened within Discord servers. I think in the last couple of months, we've seen like 100+ Discord servers being compromised, which is crazy, right? So pretty much the Web 2 piece is coming into the picture now. Now, when we move into Web 3 security and hacks, we start to talk about the compromise of smart contracts and blockchain protocols through code vulnerabilities or flaws. Now, the compromise is somewhat similar to Web 2 vulnerabilities and code attacks, but the code here is different. It's code written for decentralized finance, as we know, and smart contracts running on blockchains. So let's come back to that later. But it's worth stating that Web3 security hacks don't just stop there. Through the build out of Web3 infrastructure and the ecosystem, we've have opportunities to compromise other stuff like cross-chain bridges. Bridges have been a kind of big thing that's happened this year, and we've seen a lot of compromises there. In addition, we've seen a lot of exit scams and rug pulls. So we'll come back to that as well. Moving on here, so looking into some of the stats last year, and this is kind of another crazy stat. So last year, we saw crypto losses of around 1.3 billion in total. 2022 is already starting to look worse than last year, with over $2 billion in crypto loss, and we're only just over the halfway mark through the year. So, statistics-wise, it's turning out to be a worse year than last year. So what are we talking about when we refer to these hacks? Some of them are more notable hacks that have happened last year and this year, and are large in crypto losses, and even more surprising, how little it took to cause these issues. So some examples here: uranium finance and compound finance exploits were due to very minor code errors that were found for the exploit, while the DeFi protocol BZX hack was as a result of a phishing attack compromising private keys. And what I mentioned before, 2022 is already a year with greater losses than last year. And why is that? Bridges, as I mentioned, are a new form of Web3 infrastructure that transfers crypto funds between multiple chains. When multiple chains are involved, the losses are greater, of course, right? So three bridge attacks that happened early part of this year saw losses over $1 billion. Okay, so let's spend some time discussing the challenges involved when writing secure code. In particular, let's talk about what are common security issues when writing smart contracts, what are good code and design best practices, and how do you reduce risk in general. So how do we begin to identify common code vulnerabilities? A code audit is a great place to start. CertiK is a leading blockchain and smart contract security company who specializes in both, as mentioned, off-chain code audits, as well as on-chain monitoring and KYC services. To date, we've audited over 3,700 projects and counting, and 1,427 of those audits just over the last 6 months. So a lot of audits at high scale and pretty fast going. We analyze common vulnerabilities and issues ranging anywhere from critical to major, minor, informational, and we provide that to projects. So the question comes, how does the CertiK audit work? Well, project teams first start by presenting their code to CertiK. CertiK security experts then review the code using methods of formal verification, which is an effective process of auditing. We also use AI in the background for data gathering and curation as part of the process, and then code review techniques to uncover a list of vulnerabilities, which result in an audit report of all these findings. All projects that are audited have reports and are found. You can find them all on CertiK.com if you go to the leaderboard itself. The project owners have the opportunity to acknowledge and fix these issues before the final report is published. Now, the final report is on CertiK.com for visibility to the community. So all community can have the ability to come in and actually do their own research and look at these reports. So as an example of the 1,427 audits completed in the 6 months between August of last year and February of this year, CertiK uncovered 16,400 issues. That's a lot, of which 5,300 were critical, major, or medium, meaning that they are pretty high priority. So, generally, if we take a closer look at those 5,300 vulnerabilities, we can see that they fall into 5 categories. The first category, which accounts for the most common vulnerability found, believe it or not, is that of centralization risk. Goes against the whole principles of decentralization. This occurs when the implementation of the code goes against the practices, as I mentioned, of decentralization. As an example of that, it is owners have given privileged access to update reward balances, gaining the advantage of making a large transfer to their wallet. So you don't want to do that. The second category is logic issues. So this relates to code implementation through a incorrect interpretation of how a piece of code is believed to work. An example of that is incorrect calculation of rewards, which kind of results in a vulnerability. The third category is withdrawal issues in the code. An example of that would be, say, implementing code that ends up inadvertently locking funds in a smart contract. So that's a problem as well. Then there's access control, implementation of code, for that example, that allows incorrect access control to the wrong set of users. As an example where you're not allowed to be calling a minting function, or a particular set of users are not allowed to be calling a minting function. And finally, we have what we see is bound limit issues, where code does not implement the required bound, resulting in limitless fees. So different sets of categories here to look at. Obviously, now, given that we don't have time to go into all these categories, let's just take a look at the centralization risk itself and how we mitigate those itself. Typically, centralization risk opens up to 2 types of attacks. The first is an attack that results in leaked private keys and ultimately the hacker having privileged control over the system and data. How can we mitigate this? Well, we can remove the risk by implementing the correct code, of course. We can implement privilege access management that renounces the privilege role to the user. or we can actually secure the private keys by using multi-sig wallets, sometimes like a 2 of 3 or 3 of 5 multi-sig mechanism. We can also couple that with a time lock, which is a mechanism in code that prohibits the transfer of funds under a certain time. Or we can implement a DAO, which enables control through a community of approvers. The other type of attack or hack as a result of centralization risk is that of exit scams, or commonly known as rug pulls. In this situation, owners pump the price of a token through an aggressive marketing campaign and then take off or rug pull with the funds. Mitigation for this is kind of similar from the code implementation perspective, i.e. remove the issue of the privilege access to single owner or renounce the privileges. In addition, owners themselves can participate in a KYC verification process without being doxxed to establish credibility of the owner, so making sure that the founders are not scammers, they're not taking away with the funds themselves. And finally, of course, a DAO, again, is a way to enable control beyond a single user or owner. So finally, what I want to end this presentation with is some secure coding and design best practices. When designing and implementing software, you should write good, comprehensive design documents and white papers around what you're looking to implement, so you can have the opportunity to discuss potential issues early and let everybody else who actually can see what you're implementing read the specifications and design documents and be able to comment on that. The other one is obviously understanding what secure coding means, and that's education and using frequent code reviews to catch vulnerabilities. And then obviously running static analysis tools. There are a few out there, free ones. The example for Solidity, there's Slither, there's a bunch out there. You can actually run static analysis tools and get a reasonable good idea what's happening. Write and execute test plans. Makes sense, right? To uncover corner cases. For secure best practice, or secure code best practices, I should say, you should create a threat model. Use concepts like a blue team, independent of the development team, to assess risk and model potential threats. Independent assessment by the blue team can also be used for looking at architecture specifications of the code, as well as providing recommendations of how to mitigate threats. And of course, finally, consider an audit before launching your project. And generally, I say this to most folks in the project world, the cost of an audit is far less than what that of a hack that could result down the road. So it's important to take a look at that. So I know I went through this very quick. I only had 15 minutes. There's a lot of stuff out there. If you go to CertiK.com and check us out on resources, you'll see there's a ton of information. Check out our products as well. And if you have further questions, just feel free to reach out at bd@certik.com, where one of our business representatives can help you with your questions. Thank you for listening.